Hello everyone, hope all are doing well. Today we will start up chapter circles. Firstly, basic introduction. Circle with center O. The outer boundary we call it as circumference. Firstly, concentric circles. Concentric circles means circles with the same center. We call them as concentric circles. Next one is equal circles. Two circles with the same radii. Singular is radius, plural is radii. Two circles with the same radii, we call them as equal circles. Circumscribed circle. When a circle is drawn outside a polygon which passes through the vertices, we call that circle as circumscribed circle. Inscribed circle means the circle which is drawn inside the polygon, touching all the sides of the polygon. It's called inscribed circle. After this, we are dealing with chord. The next term is chord, one of the important terms of the chord. A line segment joining any 2 points on the circumference of the circle is called a chord. Here AB is a chord, and this chord have few results. The first one is, from the center of the circle, if a straight line is drawn to bisect the chord, it makes an angle of 90 degrees. I repeat, from the center of the circle, if a straight line is drawn to bisect the chord, it forms an angle of 90 degrees. And vice versa is also true. From the center of the circle, if a perpendicular is drawn to the chord, it will bisect the chord. After this, equal chords are equidistant from the center. In a circle, if we had drawn two chords, AB and CD, and it is said that they are of equal size, it means they are at equal perpendicular distance from the center. Equal chords are at equal distance from the center. Greater chord, if the size of the chord is greater, means larger one, it will be closer to the center, and if the size of the chord is smaller one, it will be away from the center. So the result is, equal chords are equidistant from the center. Greater chord will be at smaller distance from the center, and smaller chord will be at greater distance from the center. After this, the term is arc. An arc is a part of the circumference of the circle. Arc means this arc AB, it's a part of the circumference of the circle. The smaller part is called the minor arc, and the larger part is called the major arc. It's minor and major. And in case of arc, it is a part of circumference only. After this, we have segment. We are having a chord AB. It divides the circle area wise into two parts. The smaller area is called the minor segment, and the larger area is called the major segment. So segment means area wise, and arc means it's a part of the circumference. After this, we are having sector. If a circle is drawn and from the center two radii are drawn, the area divided, it's given the name as sector. The smaller one is called the minor sector and the larger one is called the major sector. Now moving to theorem. The angle which an arc of a circle subtends at the center is double which it subtends at any point on the remaining part of the circumference. Means if on the circumference angle is x, then at center it comes out to be 2x. Angle subtended by the arc at the center is double the angle subtended by the same arc on the circumference. It's given by theorem 5th from your book. After this, arc AB, it subtends equal angles on the circumference. Angle AMB, if it is x, then angle ANB also it comes out to be x. Angle subtended by the same arc on the circumference, it's always equal. Next theorem is angle in a semicircle. AB is a diameter, then angle subtended by this diameter in the semicircle is always 90 degree. It's a right angle. Based on these results, exercise is given in your book. From the exercise, one of the questions I am solving. It's given that AOB is a diameter and angle CAB is given as x. So they had asked find angle COB. COB, it will come out to be 2x. Angle COB, it will be 2x. The reason is that angle subtended by the arc on the circumference, if it is x, then at center it comes out to be 2x. Another one, it's given that AO is parallel to DC. These two are parallel lines. So this is angle x. Angle DCA is also x, alternate angles. Angle DCA is x, then angle DOA will be 2x because angle on the circumference is half the angle subtended at the center. So question is find DOC. AOB is a straight line. Angle AOB is 180 degree. Out of this one is 2x. Angle COB is also 2x. So angle DOC, it will be 180 minus 4x. Third part is angle DAC. We have to find this one. If angle DOC is 180 minus 4x, angle at the center, then angle on the circumference DAC, it will be half of that one. Half of 180 minus 4x, it's 90 minus 2x. So this angle is 90 minus 2x. Last part is angle ADC. This angle. It's a triangle. Sum of the angles of a triangle is 180 degree. So angle 90 minus 2x plus angle ADC plus x is equal to 180 degree because we know that sum of angles of a triangle is 180. And when you will solve it, you will get angle ADC as 90 plus x. It's 90 plus x. So in this way you have to try out the questions from A exercise. After this, proceeding with the next topic, that is about cyclic properties. Cyclic properties. Question comes, what are cyclic properties? When a quadrilateral is inscribed in a circle, that is, the circle is passing through all the vertices of the quadrilateral is called a cyclic quadrilateral. And in this, what's the main property? One of the important theorems. The opposite angles of a cyclic quadrilateral, the sum is always 180 degree. That is, they are supplementary. So we can write angle D plus angle B is equal to 180 degree. and angle A plus angle C is equal to 180 degree, but only when the quadrilateral is cyclic. Clear? When we are having a cyclic quadrilateral, means a quadrilateral covered up with the, another result is that the exterior angle, if you extend up a line like this, the exterior angle of a cyclic quadrilateral, this angle, that is angle X, is equal to interior opposite angle. Make sure if this is angle X, then in that case this angle will come out to be X. This is exterior angle, this is interior opposite angle. Other than the common lines, the third angle which we are left with, that will be the interior opposite angle. So whenever in a cyclic quadrilateral an exterior angle is available, then it will be equal to interior opposite angle. So these are the results from the first two exercises. One question for B exercise from B exercise. Question number 5. ABCD is a cyclic quadrilateral with center O. Angle ADC is given as 130 degree. Find angle BAC. So in this case, dear, ABCD is a cyclic quadrilateral, and in cyclic quadrilateral opposite angles are supplementary. So angle ADC plus angle ABC, it comes out to be 180 degree, because in cyclic quadrilateral opposite angles are supplementary. It's given as 130 degree. So angle ABC, it comes out to be 50 degree. So this angle is 50 degree. Second is AB is a diameter angle in a semicircle. Angle ACB is 90 degree. That is angle in semicircle. So this is 90, this is 50. So the third angle, required angle, it comes out to be 40 degree. So in this way, dear, try out the questions from A and B exercise. If doubts are there, that we will clear when you will be back in school. So please try out the exercises. Hope to see you soon. Take care, stay safe. Thank you.